Okay, this is 5.8 D is in delta, and we're still decomposing into partial fractions. And one of the things I'm going to do, this is example 4 on page 514, is I'm going to go ahead and write from example 2 that we did. I'm going to go ahead and write, if you look, page 513, example 2. See where it says, then we equate the numerators, this gives us. Okay, and I'm going to write out that long equation, and then we'll go from there. Now what I'm going to do here is I'm going to look at the right-hand side of my equal sign, and I'm just going to expand everything. I'm going to take x minus 2 times x minus 2 and multiply these two together and just show you what I get there. So if I expand all that, all right, I'm going to just kind of ignore this right now. I'm just going to pretend that it's not there. It's actually going to be right here, but I'm not going to write it down there. So I'm going to go a times, and so let's expand that, x minus 2 times x minus 2, FOIL that, x squared minus 4x plus 4 plus b, and I'm going to FOIL that, 2x squared minus 5x plus 2. So this is just taking this top equation here, and normally what we are doing is we were finding partial fractions using the method we had been going over. And this time, rather than do partial fractions, I'm just multiplying everything out. And for this one I get c. I'm just going to leave it as 2x minus 1. I really can't do anything with that. Alright, now I'm going to distribute my a. So I'm going to get a x squared minus 4ax plus 4a plus, and then I'm going to distribute my b, 2bx squared minus 5bx plus 2. Okay, and then I'm going to distribute my c, 2cx minus c. Okay, and that equals this right there. So if we were to look at this, notice that, okay, see if I can do this without being too tricky, that my x squared here, what I'm saying is this whole thing equals this whole thing. So if this is 7x squared, then if I'm looking at this whole thing, this and this need to be equal to my 7x squared. So 7x squared has to equal ax squared plus 2bx squared, because those are the only parts that can add together, right? So when I'm looking at this whole thing, when I'm looking at like terms, this is going to be a like term with this. And when I add those, that's going to be 7x squared. Well, so if that equals 7x squared, then 7 has to equal my a plus my 2b. So my coefficient of my x squareds, when I add those together, they need to equal 7. So I'm going to write that as 7 equals a plus 2b. And following that same line of thought, negative 29 is going to equal whatever this is, because it's only got 1x. Let's see, another place with 1x right here, and this has 1x. So my negative 29 has to equal negative 4a minus 5b plus 2c. And again, following that same idea, my 24 has to equal my numbers that don't have variables. So this is not a variable, this isn't, and this isn't. So my 24 has to equal that, that, and that. Combine 4a plus 2b minus c. So now what I have here is a system of equations, 3 equations with 3 variables. So I can actually solve this by using systems of equations, and by solving it with systems of equations I can find that my a then is 5, my b is 1, and my c is negative 2. And then I can put those in my numerators and end up getting, get this up here, my a over 2x minus 1 plus my b over x minus 2 plus my c, which is negative 2, so let's just make it a negative sign, negative 2 over x minus 2, the quantity squared. So that was another way to find my a, b, and my c. And then I just plug them in there for the numerator, and life is good. Alright, so let's go to each and look at example 5. This is the last example. Okay, so what makes this one so much different than the other ones is all the other ones had linear factors, and sometimes they had maybe a 2 or a 3 up here, but what was inside the parentheses was linear. This one is not linear, so that puts a little bit of a kick there that makes it a little bit trickier. So what you do when your inside your parenthesis is not linear, remember how we had like a over 2x squared minus 1, and then we had a b over x minus 3. Okay, there's a little bit of a tweak here that we need to do because that's not linear there. So what we have to do is whenever we have something like this where we have 2x squared minus 1, we have to put our numerator as ax plus b, which means this is going to have to be a c. Okay, I don't know why they make you do that. I have no clue why that is the case. I haven't gone through the theory to figure that out, but that's the way you do that. So whenever you've got an exponent here on your variable and you can't get rid of it, you can't make it into a linear factor, then you write this form up here, ax plus b. Okay? Alright, so let's go ahead and find common denominators here. So I am missing on this left-hand side an x minus 3, and I'm missing over here a 2x squared minus 1. So I'm just going to write that all out, and I'm not going to write the denominators any longer because those are basically going to go away once I find common denominators. So 11x squared minus 8x minus 7 equals ax plus b, and I put that in parentheses, and what am I missing? I'm missing an x minus 3 over there. And then over here I have a c, and I'm missing a 2x squared minus 1. Okay, so skipped a few steps there, but I think you can follow what I'm doing. Alright, so now this goes into what I did on the last one where we used systems of equations to figure this out, because it's going to be pretty difficult to solve for a, b, and c when at this point, notice, I only have 2 terms here. I've got an a and a b here, so I'm not going to be able to put in a number here to make this 0 because I'm still going to have an a and a b left over that didn't go away. Or if I put a number like 3 in here, that'll go away, but now I've got this mess here, and when I plug this in, I'm not going to be able to get away from or get the a and the b because they're connected. So I end up not being able to use the regular decomposition of functions. So that's why I showed you the last example, so that we can come to this example, you can figure out, okay, there is an alternative to doing this. So I am going to FOIL this here. So I get 11x squared minus 8x minus 7 equals ax squared, the first one, and then 3ax outside, inside, last. And then I'll just distribute my c there. 2cx squared minus c. Okay. Now again, I'm going to look and I'm going to compare. This 11x squared is going to be this and this put together. So this here and this here is going to give me my 11x squared. So I'm going to say that 11 then is got to be equal to a, this a right here, plus 2c. Okay, let's try another color here. And this 8, negative 8, is going to be equal to negative 3a, and the, let's see, what do I have here? Oh, the b here, because that's a bx. So negative 3a plus b, because I just looked for all the x's. Now I'm going to look for just the numbers. We'll do that in white. Negative 7 from right here equals, there's no x here and no x there, so negative 3b minus c. There is my system of equations. So I'm going to use my formula for finding system of equations, and I will find out that my a is 3, my b is 1, and my c is 4. So then I can take up here and put a 3 in for a 1 in for b, and a 4 in for c, and that then would be my answer with these numbers in their place. Now as I'm looking at this, I'm thinking maybe you don't remember how to do systems of equations with 3 variables and 3 equations. So let's go ahead and see how we got 3, 1, and 4 here by actually doing this. Okay, so we have 11 equals a plus 2c, negative 8 equals negative 3a plus b, negative 7 equals negative 3b minus c. Alright, so what I'm going to do here is I am going to look at my first equation and my last equation, and I'm going to look at just those two. So if you can look at those for me, I'm going to get rid of my c's, because if I get rid of my c's, I have an a and a b left there, and I have an a and a b there. So then I can take the answer of combining this first and third and combine it with this one. Okay, so if you don't get that, just follow along with what I'm doing. And the third one, I didn't realize the book didn't go over this or show you this. Alright, so I'm going to multiply this bottom one here by 2. And I end up with 11 equals, put the first one there again, and that equals negative 14 equals negative 6b minus 2c. Okay, so I'm just going to add these together because these will disappear if I add them together. So 11 plus negative 14 is negative 3, and then a minus 6b, there's nothing to compare there, so those go away. Alright, so now what I'm going to do is move some of this junk out of the way here. I have an a and a b here, and I have an a and a b in this equation, so I'm going to put those together. So negative 3 equals a minus 6b. Negative 8 equals negative 3a plus b. And I'm going to add those together, so I'm going to multiply this one by a positive 3. So then I get negative 9 equals 3a minus 18b, and this will stay the same, negative 3a plus b. Add these together, negative 17, those go away, equals negative 17b, so my b equals 1. Okay, so at this point I can plug a b into these, and I can just go ahead and find my a and my c based on that. So I'll just leave the rest of that to you.